In the last section, we learned that there could be 7 different species of EDTA in solution. The complex formed by Y-form negative with 4 negative charges and metal ions is the most stable. Today, we will study the stability constants of complexes and the distribution of complex species. For 1-to-1 complexes, such as the metal EDTA complexes, the formation constant is expressed as Kmy. The larger the Kmy, the more stable the complex is. On the other hand, the dissociation constant of the complexes is denoted as K-dissociated. The larger the K is, the more reliable the complex is. For complex of 1 to n, such as unnatantate ligand ammonia, it stepwise reacts with cupric ion to form the complex couple ammonia. The stepwise formation reaction and its constant are represented as follows. The first step formation constant K1 describes the complexation of copper ion with one NH3 molecule, producing CuNH3 2 positive complex with one ligand. The second step formation constant K2 describes the complexation of CuNH3 2 positive with a second NH3 molecule, forming CuNH3 2 positive with two ligands. The third step formation constant K3 describes the complexation of CuNH3 2 positive with a third NH3 molecule, forming CuNH3 2 positive with three ligands. The fourth step formation constant K4 describes the complexation of CuNH3 2 positive with a fourth NH3 molecule, forming CuNH3 2 positive with four ligands. These four formation constants decrease gradually, indicating the gradual weakening of stepwise complexation. Based on the above examples, we can summarize the general expressions of the stepwise formation constants and their corresponding stepwise dissociation constants. For the convenience of complex equilibrium calculation, the cumulative formation constant beta is usually used. The overall reaction M react with NL produce MLN as a total result of stepwise complexation reactions. The equilibrium concentration on complex can be calculated by using the equilibrium concentration of beta, M, and L. After starting the acid-base titration analysis, we know the distribution of polyprotic acids loses importance. The products of complexing agent and multiple proteins are also polyprotic acids, and their existence has an important influence on the main reaction of complexation titration. Therefore, it is necessary to understand the protonation process of the complexing agent. The complexing agent combining with hydrogen ion is called the acid effect. The protonation constant of complexing agent is expressed by Kh, which is a reciprocal of Ka. The relationship between the stepwise protonation and cumulative protonation constants of EDTA is as follows. The concentrations of various species of the EDTA protonation can be calculated by using beta H, Y, and hydrogen ion. Now let's discuss the distribution fraction of complexes in each stepwise formation in the solution. Delta is a ratio of equilibrium concentration of a certain species to the sum of equilibrium concentrations of all species. Here is a distribution diagram of composition of coupled ammonia complexes solution as a function of ammonia concentration. Because the difference between adjacent formation constants is small and their values are not large enough, there are several forms of coupled ammonia complexes in the solution when NH3 varies in a large range. The complexation reaction could not be carried out according to a certain stoichiometric ratio, and the end point of titration could not be recognized. Therefore, ammonia can't be used to titrate capric ion or other metal ions. This actually answers the question of last class. Not all complexation reactions can be used for complex matrix titration, and the one-to-one quantitative complexation of EDTA with metal ions is one of the reasons for its wide application. After today's lecture, we know the stepwise formation constant and the cumulative formation constant of complex, as well as a calculation of the stepwise protonation constant and the cumulative protonation constant of EDTA. This part builds the foundation for the subsequent study of the side reaction of complex titration.